So what is the difference between a population and a sample? I think this picture does a really good job. I mean, if you did sample by scooping out a net full of fish, I don't know if that's the right sampling technique, but that would be a possible way to sample these fish. So we might be interested in all of the fish in the sea, and if we could know everything about all of them, then that would be a census. But a sample is when we study a subset of the whole just because it's more manageable. So sample is part of the population, population is everything. And what the population is will vary depending on whether we're interested in all of the people in the entire US, or if we're only interested in LCC students, or maybe I'm only interested in LCC stat students. So all of those could be my population. Those are the ones that I'm studying. And then the sample could be a smaller collection from that population. And if I don't sample properly, I will not have a representative sample. Meaning that if I survey in a way that I only get the students who are A+ students, then I'm not hearing from the other students. And this is an ongoing challenge, as we'll see. Now, the statistic is going to either be the average or the percentage, but it comes out of the sample. So that's what you need to remember. And S goes with S, so a statistic comes from a sample. The average height is a statistic, or the percent of my students who are left-handed, that would also be a statistic. A parameter is a property of the entire population. And the parameter is often unknown unless we literally could survey every single person in the population. And it's kind of handy that P goes with P and S goes with S. So X bar stands for the sample mean, and that's a statistic. And P hat would be the sample proportion. So if we got P hat equals 0.09, then I would say, oh, 9% of my students are left-handed. That would be a statistic. So we need different symbols to represent the parameters. So mu represents the average from the population, and P represents the proportion from the entire population. So going back to this question, how many siblings do you have? The population is the entire group. We could say that I'm studying all LCC students. So let's just go with that for now. And then I'm sampling only from my students in statistics. So that's my sample. The parameter is the average number of siblings for all LCC students. So notice it is the average, but it's the average from the population. And the statistic is the average from the sample. My variable is the number of siblings, and X represents that. And the data is all the numbers that I got from the survey. We want a sample that's representative. So you might criticize me if I'm trying to study all LCC students by only serving surveying my stat students, and you'd be right. My stat students might not be representative of all LCC students. You might be different, you might be further along in your studies than a lot of other LCC students. You might be more likely to be in a medical or social science profession, as we saw earlier. So you're not representative of all LCC students. We might need a different sampling method to get a representative sample. So we could do random sampling, and I could try to randomly sample out of all LCC students. I could do a random sample out of a class of 70 students. There is a way to generate random numbers on your calculator. I don't have that calculator available to show you the method, but if you were going to try, or if I was going to try surveying my students out of a class of 70, then I could use the random number generator and then pick student number 12, number 17, number 37, and so on. There's some other sampling methods as well. So stratified could be, oh, just a second. Okay, just wondering if this was cutting off weirdly. I'll pull that up a little bit more. So to explain this, I'm going to go back to the example of all LCC students. For stratified sampling, I could divide LCC students into groups called strata, and then take a proportionate number from each stratum. So the example that comes to mind for me is to divide LCC students into all of their majors. And then if I have a really big group of students in a major, I would sample more students from that major, say nursing students. I would make sure to get more students from nursing, and if there's a really obscure tiny major, then I might sample fewer students from that major. So that's what proportionate means. Cluster says, I'm going to divide LCC students into their majors, but then I'll just select some of those majors to study. I can't handle surveying all the different students in all the majors, so I'll just select a few. So that's the cluster method. And then systematic would be if I chose every 50th student. So if LCC has some giant list of all the students, I would go down the list and pick every 10 or every 50 students. What I'm doing in my class is convenience sampling. So for me, it's convenient to simply survey my students. And then one last thing is with or without replacement. If I say with replacement, then that means after you were randomly selected, you get put back into the pool of people that could be selected again. Without replacement means after you've been surveyed, you're no longer going to be a candidate for being surveyed again. So that's the difference between those two. And I think I just have a couple more slides. Sampling errors. Yeah, there's a lot of mistakes you can make with sampling, and if you were going to be a real professional researcher, then you would take a class on sampling methods and go a lot deeper into this. But if you don't have a very big sample size, you're going to have a problem with your survey results. If your sampling method is going to be biased towards some people and you're not going to be hearing from other people, then that's sampling bias. If people choose to respond, then you're going to be biased because you're going to get the people who self-select into the study. And then even if you don't self-select, you could get non-refusal, a non-response bias. So even if I selected the right students to be in my survey. If some of them don't participate, that creates a bias in my results. So finally, we will see variation in samples. So if I did a study of LCC students and I surveyed, let's say, 300 LCC students, and another researcher also surveyed 300 LCC students, we might get slightly different results, even if we were doing a really good job. And so there's natural variation in samples. There's going to be a little bit of variation, but it should not be dramatic. So if my results and the other researchers' results were dramatically different, it could be because of some factor that we hadn't considered yet. So you can go complete page 4 of that activity. And I do have some more slides here with additional information. I'm probably not going to be asking you questions about this, but you might be interested in it, especially if you're going to go on to study psychology, or anybody who's going to be reading research papers, even medical research. You may want to read a little bit more about this. And this is an example of a consent form for a study that we did with some students a little while ago. Just being full disclosure to your students if you're gathering data from them. And I certainly don't have a consent form for my survey. It's very informal, but it's anonymous, so I think you're pretty safe in that study.